in this section, let's learn about load balancers, and I'm going to show you how to configure one and how it works in detail, and also show you the best way of you taking advantage of load balancers as you deploy your applications. So in a typical application, you have the clients, this is the internet, and this right here, let's say that this is a VM somewhere on the cloud with this particular public IP address. Now, so far we've been creating microservices, and we have one which is customer. So this handles customer registration. Now this right here, so this setup where you've got one client or two clients or maybe three clients using one particular instance to register the application is absolutely fine. If you are working on a personal project, then this is fine for you to build because the setup it's really easy. All you have to do is you spin up an instance somewhere on the cloud with a public IP address, and then you can access this instance. So let's say that your application is becoming popular day by day and it's actually receiving more traffic. So let's say that you went from 1 or 3 clients to 10,000 clients using your application. The problem that you're going to have is that one, you either need one really big machine, i.e. one VM with 32 or 64 cores, lots of RAM and other high spec, right? So this might solve the problem temporarily, but still doesn't scale. If you go from 10,000 clients to 100,000 clients, then basically you kind of have to do something else. So usually what you do is you have multiple replicas of your application. So in this case, customer. So here you can see that now I do have 3 instances. So this is one instance, another instance, and then yet another instance. Now, the problem here is that these clients right here that are connecting to your backend system, right? They don't know which VM to connect to. So if they all connect to this one, then this one will run out of resources, leaving you with these other instances receiving no traffic. Or maybe you could actually implement some logic in here that has a list of all IP address for all of your instances, so on and so forth. But no one does that. So how are you meant to access your applications in this scenario? Well, this is what load balancers solve. So to fully understand this, let's take our architecture that we currently have and let's introduce load balancers so you see how it works. So in here, this right here is my private network in here. And what I have is an external load balancer. So this external load balancer, this is the main entry point for any client that wants to connect to your applications. So instead of clients going directly into customer or fraud or notification, you say the main entry point is through this external load balancer. Any traffic that goes from the internet directly into these instances inside of the private network will be blocked by the firewall. So a request comes in through the load balancer, and the load balancer is actually quite smart. So there's a lot of things that you can configure within it. But let's say that you want to send a request to customer. So this request right here is sent to this other load balancer. Now, this is an internal load balancer, and the reason is because you might have multiple instances of customer or fraud or notification. So the same problem that you are solving from the outside world connecting to your services is going to apply within the private network, because these communications right here, so this is an internal communication and this is a communication from service to service. So you also need an internal load balancer. Now the configuration between this load balancer and this load balancer will be a little bit different, but I'll explain more in details in a second. And to be honest, this is load balancers. Now, there are a lot of things that we have to take into account, such as TLS, certificate management, authentication. Where do you authenticate the requests? Do you authenticate the requests within every single microservice or within this external load balancer? Do you terminate TLS in here or through these services in here? How do you make your load balancer high available? Meaning that it's always up and running no matter what. Is it cross-region if you're running your application in multi-region or not? Logging, caching, path-based routing. So in here, you see that instead of having multiple external load balancers for each of our applications, we can just have one. And then based on the path, we can redirect the request to the appropriate internal load balancer. Now you can see that this actually is quite a lot of work to do. And most often when you run applications in production, you should choose a managed load balancer instead of managing your own, because this right here is the main entry point for your application. So if this load balancer dies, right? So let's say you are managing the load balancer. If it dies, then you can see that this is a Sev1 incident immediately, right? So we actually let cloud providers manage this for us so that we can just, again, focus on our microservices and our own business logic. So let's take a look at the cloud load balancing provided by Google Cloud. So in here, you can see that they give you some information about it, what it is. But in here, let's just take a look. Have a look. Over 1 million queries per second. So you can see that if we were to manage our own or set up our own, then it can be quite challenging for us to reach these numbers. Seamless auto scaling. So can scale as your users and traffics grow, including easily huge, unexpected, and instantaneous spike. So maybe there's an advert going on, so you can expect, a bunch of traffic coming your way. So this scales out for you without you having to do anything. Internal load balancer. So as I was saying, for internal services. So you can see support for cutting edge protocols, HTTP, HTTP2, gRPC, HTTPS as well, load balancers. So you can see right here, cloud logging, TCP, SSL, SSL, offload, affinity, CDN, and the list goes on and on and on. The same with AWS. So they provide either an ALB or gateway load balancer or network load balancer, and they give you some information how it works in here. So the same thing as the one provided by Google Cloud. And if I click on features, for example, have a look. So these are all the features that it provides. So redirects in here, path-based routing, IAM, health checks, SSL offloading, clouds as a target, logging, so on and so forth. HTTP header based path routing. So this is really important and one that we want. And you can see all the protocols listeners, the same with the targets, whether you want to target to an IP, an instance, or a Lambda. So this is a really cool feature for serverless applications. So you can see the benefits of a managed database. Now, if we were to actually, I didn't even show you. So SSL, so certificate management. So all of this is actually integrated. Now, if we were to manage all of this ourselves, you can see that it's quite challenging. So also Nginx. So this actually provides you a load balancer as well with some of the features that you'll see, and you can read more about it, how to configure one with Nginx if you want to learn how all of this stuff works. But basically, this is why you really should use a fully managed load balancer when running your applications in production. Next, let's go ahead and learn how the load balancer works.